Hello, BookTube, and welcome to your daily paper. This is a series of videos in which every day I read a paper and I come to you and I talk about the paper. So, the paper I've read today was this one. I have my trusty laptop over here. Whole cell patch clamp recording in brain slices. I don't think you can see that. Anyway, whole cell patch clamp recording in brain slices, which is about patch clamping neurons in brain slices. Uh, it's a technique paper. There isn't much to say about it. It's a paper explaining and standardizing the electrical physiology, how do I say it? Electrical physiology technique to study the electrical properties of neurons in brain slices. You can use this to study the electrical properties of neurons in cell cultures, but I was reading it because I was interested in how to use the technique in brain slices. I did some a course on this technique last year, like at the end of the last year, but I had to refresh my memory on how the specifics of the technique worked because I'm writing my PhD project, research project, and one of the experimental protocols that we are going to try to do is wholesale patch clamp to study the how some drugs affect the the chemosensitivity in the art in the of the neurons in a area of the brain called retrotrapezoid nucleus. So what this techniques allows you to do is you have brain slices, you dissect the brain, and you cut some very thin slices of the brain, like 300 micrometers. There's a special machine that slices the brain very thinly, and then you can use some micropipettes to record the electrical signaling of the neurons in that area. One thing that I did not remember, and this paper was quite useful to remind me of, was the difference between putting cesium and putting potassium in the micropipette that you are going to use to record in the brain slices. And I wasn't sure if for my project we would use the cesium preparation or the potassium preparation. And reading this, I figured out that I'm taking a look at the paper, but that's why I'm looking at the side. I don't think I should do that. That is bad for people who are watching. It must be kind of annoying if you're constantly looking at the side. My first time doing this. Who would have thought? Anyway, when you do a cesium preparation, that kind of freezes the neuron, but when you do a potassium preparation, that allows you to understand the firing of the intrinsic firing pattern of the neurons. And because we are what we are trying to do is to understand if some drugs will affect the increase in firing rate that these neurons have when you expose these neurons to a lower pH or a higher concentration of CO2. We had to use the potassium preparation because that would not freeze the neuron and would allow us to cause this firing through increase of CO2, and then see how this increasing firing through the increase of CO2 would be affected by adding one drug, and specifically the combination of two drugs. We are interested in the combination of two drugs. One is a agonist of melanocortin receptor, melanocortin type 4 receptor, and the other one is a antagonist of orexin receptor, is a dual antagonist, orexin 1 and 2 receptors. And we want to get in the nitty gritty of the electrical properties of these neurons, and that's why I was reading this paper today. Quite useful. I really don't have anything else to say. There are no results. This is not a new technique. It has been standardized for decades already. It works quite well. And if you are interested in electrophysiology and whole cell patch clamp, this paper is a good way to to get some specifics on the procedure and how to use it. The steps, the paper gives you the step by step. At the end, it also gives you some results that are acquired from in other papers to, to exemplify what a technique can do. For example, in this paper, they use using the potassium preparation. They give us an example: the increasing firing rate that happens in neurons when you increase the temperature. So you have like 24 degrees temperatures and you have a standard firing rate. Then you increase the temperature to 29 degrees Celsius. I don't speak nonsensical units. The firing rate is the same, but then when you increase the temperature to 32 degrees, there's an increase in firing rate, and then you can use and then the paper shows how you can use the how which preparation of this technique and which steps of this technique you have to use to do this kind of study. Quite useful, but there isn't much else to say. Is a uh, kind of just more technical. But I read a paper every day. Sometimes I read more than one paper every day. That's the life of a scientist. You have to read a paper every day. And today that was the main paper that I've read. And well, thank you for watching and see you tomorrow.